Hello, let's learn some slightly more advanced features about plotting with Python. We'll talk about putting labels on the axes, making a legend for your plot, using subplots and 3D plots, and also saving plots to a file. So I'll start off with a basic plot. You can pause the video and see what I'm doing there, but just plotting sine and cosine like this. If you want to get rid of this little gap here, you can set the axis labels a little bit differently. You can do something like this. So I can set xlim to go from tmin to tmax, which is just the maximum and minimum values of this t. Of course, we could have put minus np.pi or np.pi there, but this is just a quick way to do it. If we plot, we see we've gotten rid of the gaps. Okay, so now we have a nice plot, but it's looking like it's missing some things. We need some labels, maybe on the x-axis or y-axis, that kind of thing. So to play around with this, let's first we'll move the plot show down. We want to load in all this information into the plot first. So maybe first we could do something like plot.title. And you want to give your plots interesting titles if you can. Maybe here we're plotting something like input and response to some signal. We run that. We get the plot title up there. And then we can similarly add the other elements of the plot as we like. So next we might do something like plt.xlabel. Maybe this is time. plt.ylabel. And this could be amplitude, something like that. I'm using single quotes to highlight these. So as we click, there we have time on the x-axis and amplitude on the y-axis. It can sometimes be useful to have a legend. So here we'll do plot.legend. So if you're familiar with MATLAB, this will look very familiar. We could do something like input signal. So what this will do is show us that the first plot here, corresponding to the first entry here, it'll show us a color code for that. And here we can do something like response signal. Should keep them consistent. There we go. And then plot.show, take care of the rest. So our legend, oh, sorry, I have a little issue. Oh, I'm sorry, I need square brackets between these. There we go. So square brackets to input a vector of strings here. If we run this, then we get the blue is showing up as an input signal, the orange color is showing up as response signal. And that's just corresponding to the first and the second. So for instance, if I switch the order in which these were plotted and did that again, then my I would have these would be showing up backwards from what we had before. If we have something like plot dash star, these will also show up. If we run forward, then we see a little star showing up here in the input signal, indicating that that's this particular plot. All right, great. So it's important to have labels and legends, things like this in plots. It can really make things a lot clearer. And sometimes if you're submitting a paper or something like that, your paper might, the reviewer of your paper might give you a hard time, for instance, if you didn't include axis labels, legends, and other things. Okay, maybe we have a pretty nice plot at this stage, and what we'd like to do is save it. So in order to save it, we need to have some way of interacting with the plot. And to do that, before we start this plotting, we will build a figure. So we need something like plt.figure, and then just open parentheses there. But I need a way of, so what this will do is open up a region for the plot to go in. But I need to give this some type of what's called a handle, something I can manipulate this thing with. So I'll call this thing FH for figure handle. That says, okay, I just have this empty figure that I'm plotting into. I'll label, later I will put some stuff into this plot, but for now, I just have sort of empty figure I'm starting out with. But that allows us to then save this thing. So I could do something like fh dot save fig, parentheses, I will plot dot png if you want to save as a png. And then when we run the thing, we, well, it may be hard to see, but this is saved right into the same directory as where, same folder, if you like, of where this plot practice thing is saved. You could save it also as a JPEG, very similarly. It will automatically detect the ending of the this MIME type down here. It'll automatically detect whether or not it's a PNG or JPEG and save it in the appropriate format. I like to sometimes use both because sometimes you need, for certain applications, you need a PNG, for others you need a JPEG, and you can experiment with other file formats as well. So that's a little bit about plotting. Main idea is just to give yourself some type of a figure handle here that you can then manipulate and act on later. Okay, well, with that discussed, let's go on to talking about subplots. Occasionally, you might want to have, maybe you don't want these two plots on one screen, so you could do something like this. Excuse me, you don't want them necessarily both on the same axis. In this case, we can use a subplot. So I can do something like PLT and then subplot. And here I'll say it's a 1 by 2 subplot. And then this is the first subplot. After that, I can say that this is the same 1 by 2 plot. That's how the figures will be arranged. And this is the second one. So the first two, tells me the number of rows for the subplots. This tells me the number of total columns. And then the last line is just indicating which number of plot we're doing. In this case, I would have to, I want X labels. Well, let's see how it looks right now. If we run this forward, we get that so we have two subplots here, as we were maybe hoping, but what we have is that all of that information, the amplitude, the time, input, the title, the input signal, all that stuff is put onto the rightmost plot. Because when we declare a subplot, we now have all the information is everything coming after that is pertaining to just that subplot. So here we have the title, the labels, and the legend all applying only to the subplot. So we could do something like copy this and paste, giving ourselves maybe a little more room. But of course, now this is, we have, our legend isn't quite correct. The first one was just for the input signal. So maybe something like this. The second one was the response signal, and then the titles will be different as well. So this one is response, this one is input. We're being a little bit redundant here, but just to give you a quick example, if we run this forward, we now have something like this. Notice that our tightened axes are not showing up, so we would need to insert those as well. We could do that before or after the plot here. So for instance, here and here, just copy pasting those. Now our X limits, the X limbs are nice and tight. We have a nice crisp view on our plot. And it's looking pretty good. So just to give you one quick example of what this would do, if I had done 2, 1, so that would mean 2 columns, 1 row, I would get something that looks like this. So vertical stacking. You can experiment around. It's pretty common in papers to see 2 by 2s or even sometimes 3 by 3s or other combinations. So that's a little bit about subplots. Let's finish off with a 3D plot. In order to go 3D, it's not all that bad. Of course, you can get pretty fancy with some of the plotting options here. I'm going to show you a basic 3D plot just to give some indication of what can be done with this, what some of the capabilities of matplotlib are. For that, I'm going to get rid of most of this. I'm going to import still matplotlib.pyplot, but I'll need one extra trick, which is that I will need to use, so I'll use a linspace here, linspace x and linspace y, like this. So we're going from -2 to 2, using 50 different points here. But after that, I can't just plot with x and y here. What I need is some way to kind of combine the x and y values, because these are just linear values, these are just arrays, one-dimensional arrays, and I need something which is a combination of these to get something two-dimensional. So here, it's common to use something like capital X and capital Y, which in Python are distinct from lowercase x and lowercase y. And then we'll combine these using mesh grid xy, like this. Sorry, mesh grid. There we go. So np.meshgrid will combine these values. And you can take a look at what this does. So for instance, if I run this in the command window down here, if we take a look at x, we just have a list. It looks like a matrix, but it's just, there's a comma at the end. So this is just the line is wrapping around, similarly with y. But if I look at capital X, this is now a list of values. It's not showing everything here because it would take up quite a bit of the screen. So this is, in some sense, I believe 50 by 50 array of values here, taking into account all of the different combinations of x and y coordinates that we could have. Okay, so now that we've got our capital X, capital Y, we can use this to make maybe kind of a simple plot. So something like z, it's equal to, let's take the sign. So we'll use the numpy sign, x squared plus y squared, and using the capital X and capital Y there. And of course, I'm a Python, excuse me, I'm a MATLAB native, so I have to remember to use * in Python and not the hat is in MATLAB. So let's use so something like this. And then after that, we need to open a figure. So fig plt.figure. And then one thing that's a little bit different in 3D is we actually need to say something about these about what type of axis we want. There are many different ways you can view a three-dimensional image. So I'll do something like this: add subplot, and then projection. So this sort of tells us how it should look. Single quotes 3D, and then after that, axis plot surface. So this is telling us, sort of where the camera is positioned, how everything should be looking and arranged in our plot. But after that, plot surface, the plot surface tool can just take in arguments x and y in the mesh grid format, and then z. We can then specify a color map called CMap, and we'll use Viridis. This is a nice one, but you can look up other color maps if you want to try different colors in your plots. And let's see how this goes. So there we have a nice color plot. We can move it around just by click and drag. And that's basics of plotting in 3D. Of course, there are many, many options you can use. There are many different ways you could create similar plots, different plots. There are a lot of options here. So I encourage you to check those out online. Thank you. Happy plotting.